All right, so let's take a question number 5. This is just a straight up just solve for x, right? So no word problem or nothing crazy here. We just want to solve for x. Now, what may make it look a little intimidating or scary is the fact that you got all these numbers, there's some parentheses, you got some x here, x over there. So the only thing that we want to do, and this is why I got a little homeboy over here in the corner. Come here. We just need to clean it up. That's why he's got his broom. So you got stuff spread out all over the place. You got x's over here and over there. So it looks scary because you just got stuff spread out. So we just need to bring him in. We're going to sweep it up. We're going to clean it up. Now, the first thing that you want to do with this is that you always want to distribute when you see parentheses. That's going to be the first thing you're going to do. So as I take a look at this, I'm just looking at what's in front of each set of parentheses. Well, I see that there's a 4 that needs to be distributed. And then if you look at that one, that set of parentheses, you think, well, is that a number there? What's happening there? Because you just see the minus sign. Well, technically, it's really that it's like a -1. Or if you want to just think of it as that you're distributing the minus to both things that are there. So when I do that, I've got a -3x. -1 times 3 would give me a -3. Remember, when you multiply and divide, same sign's positive, different sign's negative. Equals 4 times x, which would be 4x. 4 times -5 would be a -20. And then plus 2x. Alright, so the next part of this, and again, this is the coming in here with the broom and just kind of cleaning some stuff up, we need to combine like terms. And so what we're saying with combining like terms is that look at each side of the equation, and are there numbers that you can combine, or are there x's that you can combine? And remember that the equal sign is kind of what splits the two sides here. If I think of this as a house, it's kind of two sides of the house, this being the left side and the right side. So I'm just looking in this room, and I'm saying, well, who can I put together? Well, 19 minus 3, I can put those two together and come up with 16. And then if I look at the right side of the house, if I look at this room over here, I see a 4x and a 2x that I can put together. So if I had 4, now I got 2 more, then that means I've got a total of 6. Alright, and so now the last part of this, as far as cleaning this up, is that I want to move variables to the same side. So again, I just need to get this x, because see, I got an x here, and then I got an x over here. So what I need is I need to get them on the same side of the equation. So what I want to do with that, and it actually doesn't matter which way you go. You can move -3 over to the 6, or you can move 6 over to the -3. What you cannot do, and don't write this down, you can't do this. You can't say, oh, -3 plus 6, positive 3x. They're not on the same side of the house there. They're not in the same room, so you can't combine those two things together. So what we have to do with that is we actually have to think of it as almost kind of like physically picking up one of the x's and then moving it into the other room or the other side of the house. Doesn't matter which way you go with it. Some people like doing move the smaller over to the bigger. So if you wanted to do it that way, that would mean adding 3x to both sides. Why adding 3x? Well, because the opposite of subtracting 3x would be to add 3x. And so I've got 16 equals -20 plus 9x. Now I'm just trying to get x by itself. So I'm trying to get all the numbers. If I moved all of the x's over to the right, then all of the numbers that are just by themselves, I want to move that over to the left. So I would do the opposite. Opposite of subtracting 20 would be to add 20. And so we end up with 36 equals 9x. 9 times what number makes 36? Well, that would be 4. Right, because 9 times 4 is 36. If I wanted to show the algebra on that one, that would be dividing both sides by 9, and then get x equals 4. So it wasn't as, again, it looks kind of scary at first because all this stuff spread out all over the place, but once you combine like terms, get everybody on the same side, it simplifies pretty quickly. Alright, so go ahead and pause now and try 5.2 and 5.3. Alright, let's check in on you. If we look at 5.2, should have got x equals a positive 1. And for 5.3, should have got x equals a positive 2. Alright, so that concludes problem number 5.